The quality of your Western blot image is dependent on your protocol and the imager. That's why it's imperative for you to take your time when preparing your blot and follow the suggested best practices. Your lab may have a preferred membrane to use, as each of them do have their own advantages. However, it is best to test out your target protein on both PVDF and nitrocellulose. Now, nitrocellulose has a lower background than low fluorescent PVDF, but PVDF does have a higher binding capacity, so you can really only determine the best for your target by testing them both out. Now, the type of blocking buffer you use can have a large impact on your background and the signal intensity for your target. So before you begin working with a new target and antibody, you're going to want to test out multiple blocking buffers. After determining the optimal blocking buffer that yields the highest signal-to-noise ratio and lowest amount of background, you'll then want to optimize your primary antibody concentration. So to do this, you're going to titrate the antibody and also be sure to include the manufacturer's recommended concentration as your starting point. Washing your membrane may not seem like an important step in the Western blot process, but you can in fact over or underwash your membrane. Both types of washing will lead to inconsistent amounts of antibody on your membrane. So be sure to use a timer and wash your membrane for the same amount of time each time you wash your blot. Choosing the appropriate imager for acquiring an image of your Western blot can be overwhelming because there's so many different options available. So when you're comparing the different types of imagers, be aware of the light source. This can have the greatest impact on your signal intensity. The most common light sources are white light bulbs, LEDs, and lasers. White light bulbs and LEDs do have a reduced optical power in comparison to lasers, therefore this will generate a lower signal intensity. Laser technology does yield a higher signal intensity and sensitivity. The laser technology used in NIR Western blots is the cornerstone behind the success of this technology. The lasers give rise to the strong signal, which allows for the highly sensitive nature of NIR Western blots. Coupled with the lasers are the NIR fluorophores. Once excited, they emit a static and highly stable signal. These fluorophores can be imaged over and over again when they're excited by the appropriate lasers without any fear of quenching or losing your signal. Also, as I mentioned earlier in the course, you can multiplex or visualize 2 or more targets on one membrane. Multiplexing is ideal for probing for 2 proteins that have the same molecular weight, such as a pan and phospho target, or even several targets of different molecular weights on the same membrane. With all of the advantages for using NIR technology to acquire your Western blot image, you can see why this innovation has led to many advances and discoveries. However, to complete your Western blot protocol, you'll need to analyze your blot. So in the next course, we will discuss the analysis of your Western blot image. But first, let's watch a video of Sally in the lab imaging an NIR Western blot.